Good afternoon and welcome to Channel 5 News. The top story of today was there was a train crash at the intersection of Railroad 13 train line and Spring Avenue. Thankfully, no one has been injured in this train crash, but sadly, thousands of dollars of electronic items were damaged. So now we're going to go out to the field to Brandon, our reporter, to interview the conductor of the train to get some more information about this crash.
Good evening. I'm here at the scene of a horrible train accident. With me today is the conductor of that train. Now, sir, how fast was the train moving during this?
At the point of the collision, we were probably moving at about 50 miles an hour.
Okay. And how much does this train weigh?
The train weighs about 80 tons, and fortunately we weren't hauling any cargo with it.
Thank you, sir. Hello, I'm here with another victim from the train crash earlier today. With me is the semi-truck driver. Sir, why was your truck in the middle of the train tracks?
Unfortunately, there was quite a bit of traffic, and I stopped on the tracks, but thankfully I was able to get out in time.
All right.
So luckily, the driver and the train conductor were not injured at all during this collision. So now the next question is, how do we prevent this from ever happening again? So now we're going to bring in our resident safety engineer to propose possible solutions to prevent this from happening.
Good evening. I'm here today with a safety engineer who could potentially give us solutions to avoiding said future catastrophes. So, how can we do it?
So one way that I would like to see it, maybe experiment with different materials for the rails and the wheels of the train, just to see if that would make it stop faster. For example, I would use materials such as aluminum or titanium.
And another possible solution in addition to that?
I would put a signal in front of the tracks much earlier, just in case. So just so the train knows that if something is blocking the road, they can stop. And they have more time to stop.
Thank you.
Now that we have the ideas to possibly fix this problem, let's go over to the lab and analyze the solutions.
So now we're going to try to find the distance the train needs to completely stop and the total distance the conductor needs to react and for the brakes to start working. So we are given information, and now we're going to plug them into our constant acceleration equation, and we'll get that the distance is 556.66 feet. Now we're going to look at the second part of the problem, and we're going to use the total time before the braking begins times the velocity, and we'll get our distance of 366.65 feet. Adding these two distances, we'll get our total distance of 923.31 feet. Now we're going to compare different metals when using them for the tracks and wheels. So we're given our information, and we're going to try to find the stopping forces for each of these metals. Here's a free body diagram of the train, and note that there are two wheels at point A and two wheels at point B. Summing the forces in the y direction, we can find our total normal force, which is 2NA plus 2NB, and we found that to be 160 times 10 to the 3 pounds. Now we're going to use energy equations. We found our initial kinetic energy to be 101.336 times 10 to the 7 joules, and we found our final kinetic energy to be 0 since our velocity at the point 2 was 0. Now we're going to use work equals force times distance to find the force for the train. And we found that to be 24 times 10 to the 3 pounds. Now we're going to use Newton's second law equals the sum of the forces in the x direction, which would be the force of the train plus the force of friction minus the stopping force. And we'll plug in all our values, and we get 3 different stopping forces for each of the metals. And we found that the smallest stopping force was for titanium.
As evident from all the information that's just presented, there could have been 2 possible solutions to this disaster. One would be to use different materials for the rails and the wheels. We saw that if you use titanium on the tracks and the wheels, this would result in the smallest stopping force and would make it better and easier for the train to stop in case of an emergency. The more practical solution would be to use sensors and signals to detect if a truck was stopped in the middle of the track, and then to put these sensors at the minimum distance the train would need to stop. So this would be the best solution for the problem. Thank you for watching, and stay tuned for more updates.